Hello everyone, myself Sanjeevani Surendra Chaudhary. Today's my seminar topic is Bragg's method of X-ray diffraction and Debye Sherrer method. In this we have to discuss about X-ray diffraction, Bragg's law, Bragg's equation, application of Bragg's law, Debye Sherrer method and application of X-ray diffraction. In this we have to use X-ray. The X-ray is a short wavelength electromagnetic radiation produced by the deceleration of energy of electron, and it is used to produce electron from inner orbital. Let's consider these are the orbitals. This X-ray is used to produce, it is incident on the inertial orbital and eject the inertial electron. Then the penetration power of X-ray. These are the two types: hard X-ray and soft X-ray. The hard X-ray which have the high frequency and have the more energy, and soft X-ray which has the less penetration power and has the lower energy. Then diffraction. Diffraction is a wave phenomena in which the apparent bending and spreading of the wave when they meet to the obstructions. Means this is the surface. When the X-ray is incident on the surface, it is not transmitted through it, it is diffracted in the different direction. Then X-ray diffraction. It is a technique which is used to determine the atomic and molecular structure of a crystal, in which crystalline atoms cause a beam of incident X-ray to diffract into the many specific direction. And the atomic planes of a crystal cause an incident beam of the X-ray to interfere with one another as they leave the crystal. The phenomena is called as X-ray diffraction. When there is a crystal, when the incident X-ray is incident on this crystal, it is diffracted into the different direction, and this is used to determine the atomic and molecular structure of a crystal. Then Bragg's law. Bragg's law gives the angle of coherent and incoherent scattering from a crystal lattice. When X-ray are the incident on an atom, they make the electronic cloud move as does any electromagnetic wave. The movement of these charges radiate wave with the frequency is known as relay scattering. First of all, relay scattering is the scattering when the frequency and energy of the X-ray light is same as the reflected light. Means these are the crystal or the substance. When the incident light is incident on the crystal, it is reflected in the same energy or frequency. So there is no exchange of the energy takes place. Then the Bragg's law. In the Bragg's law, various apparatus are used, such as X-ray tube, colorimeter, filter, and crystal and detector. So X-ray is incident on the crystal from the X-ray tube, and it is transmitted through the match filter and colorimeter, and it is incident to the crystal, and it is diffracted into different direction, and this diffracted ray is detected in the detector. Then a similar process occurs upon the scattering neutron wave from the nuclei. This re-emitted wave field interfere with each other either constructively or destructively, producing a diffraction pattern on a detector or film. The resulting wave interfering pattern is the basis of a diffraction analysis. The analysis is called as Bragg diffraction. Then these are the two layers of the X-ray. Which is denoted by alpha and beta, and the two incident light which is denoted by A and B, and which is diffracted into the two waves such as C and D. So put a perpendicular OY. So here the form the angle is XOY is equal to theta and ZOY is equal to theta. So theta is a glancing angle. So glancing angle means the angle between the incident light and surface. Then consider AO is equal to BY and CO is equal to DZ. Then the part difference formed between the XY plus YZ. So what is the part difference? Part difference is defined as the integral multiple of a wavelength, which is denoted by n lambda. So n lambda is equal to XY plus YZ. So there is angle is present. Sin theta is equal to L upon H. L is the length of the perpendicular and H is hypotenuse. Now consider the triangle XOY. So in this, sin theta is equal to XY upon OY. So XY is the length of the perpendicular and H is the OY is the hypotenuse. So rearrange it. XY is equal to OY into sin theta. So value of OY is equal to d sin theta. In the second crystal, ZOY is sin theta is equal to ZY upon OY. So rearrange it. ZY is equal to OY into sin theta is equal to d sin theta. Now put the value of XY and YZ in the equation number 3. So NY is equal to d sin theta plus d sin theta. Then lambda is equal to 2d sin theta form. This is the equation of Bragg's law, where the n is the order of diffraction. There are two layers of the crystal present, so the order of diffraction is 2. Lambda is the wavelength of X-ray, d is the integral planar distance, and theta is a glancing angle. So there is a different theta is angle is present for the sin theta. Sin theta is equal to 0, 30, 45, 60 and 90. So sin 0 is a 0, sin 30 is 1 by 2, sin 45 is equal to 1 upon root 2, sin 60 is equal to root 3 by 2, and sin 90 is equal to 1. Then the application of Bragg's law. Bragg's law is used for the many of the purposes. The solvent Bragg equation gives the d spacing between the crystal lattice planes of a crystal atom that produce the constructive interference. A given unknown crystal is expected to have the many rational planes of atom and in its structure. In the X-ray diffraction, the inner planar spacing of a crystal is used for the identification and characterization purpose. The computed topography is used to scan inside the body with the help of the Bragg's law. The ultrasound use the echoes from the sound wave to locate the different organ inside the body and can be used to monitor the growth of the unborn baby. Then the fourth is the magnetic resonance imaging, or NMR. Use the powerful magnet to measure the water content of the different type of the body tissue. It is a slow process but generate incredibly detailed image of the body. Then the fifth is positron emission tomography. Detect the radioactive traces that are injected into the body, and EEG detect the electrical activity in the brain. Then Debye Sherrer method. In this, powder sample is used instead of the crystal. Then there is no need to rotate the specimen because there will always be the same crystal. Some crystal in at the orientation for which diffraction is permitted, means the sample already consists of the micro crystal in more amount. Here a monochromatic X-ray beam is incident on a powder or the polycrystalline sample. This method is useful for the sample that are difficult to obtain in a single crystal form. In this method, a powder sample is put into the capillary, and this capillary is put into the camera, and X-ray enter into the camera through the collimator. The powder diffract the X-ray in accordance with the Bragg's law to produce, which is used to produce cones of the different beam. These cones intersect a strip of the photographic film located in the cylindrical camera to produce a characteristic set of the arc on the film. Let's consider. Here is the capillary is present. In this, the sample is present. These are the camera. When the incident light incident on the capillary, it is diffracted into the different direction and it form a cone. This method is called as Debye Sherrer method, and it form a film. Then application of X-ray diffraction. There are many applications of the X-ray diffraction. It is used for the differentiation between crystalline and amorphous solvent, determination of the structure of crystalline material, determination of electron distribution within the atoms and throughout the unit cell, determination of the orientation of single crystal, determination of texture of a polygrain material, and measurement of the strain and the small grain size. Thank you.